All right, today we're going to talk about inscribed angles, and to do this, we're going to need to use, we're going to just see what's going on here first. So we've got a circle. We're going to mark the, we're going to make a central angle first. To do that, I'm just going to lightly draw a diameter here, and lightly draw a different diameter over here. Find the center. Okay, so that's going to be the center of my circle. Now what I'm going to do is, first I'm going to make a central circle and a central angle. So I'm just going to go ahead and use this as my central angle here. Why not? And I'm going to measure this angle. So put right down there, go to 0, slide up here. If I continue up, it looks like about 66 degrees. So that's 66 degrees, which means that arc is also going to be 66 degrees. So 66 degrees. Now, I'm going to make an inscribed angle that hits the same arc. So I'm actually going to do mine over here. Now I'll come over here. So here's my inscribed angle. And I'm going to measure this one as well. Right down there. Measure here. So, measuring correctly. So there's 30, 31, 32, looks like about 33 degrees. And that's the cool thing about central angles. An inscribed angle hits the same arc right here as a central angle. This inscribed angle is going to be half as much. So what do I notice here? The inscribed angle is equal to half the arc. So let's scoot this up here a little bit. And I'm just going to fill in this proof here. So, I'm going to prove that angle 1 is half of this arc right here. I'm going to start off with AC is congruent to BC, because all radii are congruent. That's pretty nice. It's pretty simple. That means the triangle here is isosceles. And I can turn my paper like this so you can see that it's isosceles, which means these angles are going to be congruent. Turn it back here. Angle 1 is congruent to angle 2 by the base angles theorem. Now the exterior angles theorem, well, it's been a while, so let's see here. We may remember that the exterior angle is equal to angle 1 plus angle 2. That's way back earlier in the year. So measure of E is equal to measure of angle 1 plus the measure of angle 2. Now, since they're congruent, I can say measure of angle E is equal to measure of angle 1 plus the measure of angle 1, because they're the same. Or I can say 2 times the measure of angle 1. So there's 2 of those there. Now, measure of angle E is the same as arc BD, because we know the central angle and the arc have the same measure. Measure of angle E. So by the transitive property, if arc BD is equal to angle E, and if E is equal to 2 times the measure of angle 1, measure of arc BD is equal to 2 times the measure of angle 1. Or we can say measure of angle 1 is half of arc BD. Continuing on here. If I've got measure angle 1 right here, and this arc here is 82 degrees, how much is angle 1? Well, we just found out it's going to be half as much, so that's going to be 41 degrees. Angle 2 here is also hitting the same arc. This arc right here is angle 1. So that's also going to be 41 degrees. So if two inscribed angles hit the same arc, then the angles are congruent. Now let's do a couple example problems down here. Okay, so right here we have this. This arc is 150, so the angle is going to be half of that. So 2x plus 1 is going to equal half of 150. So that means 2x plus 1 is going to equal actually 75. And we can solve from there. And we get x is equal to 37. Since this one and this angle both hit the same arc right here, both hitting the same arc, they're going to be congruent. So 2x plus 40 is equal to 6x. And we can solve from here. And x is equal to 10. This one's a little bit tougher. This is 92. This is 144. So that's going to give me 216 degrees. But that's not the whole, that's how much this is. We need to figure out how much this arc right here is. So we're going to subtract that from 360 and get 144. So this is 144. So this angle is going to be 72. Or half of 144. Okay. Looking down at what happens if we have got angle inscribed, different angle inscribed in a circle. What we have here is right here. I'm going to measure this angle. So measure that thing and extend that. Oh, that's 90. Okay, great. So that's 90. That's 90 degrees. Arc ADC. Well, let's see here. That's good. That looks like it's 180 degrees because it's a semicircle. Well, let's check here. I'm going to draw AC. Yeah, that's a semicircle, isn't it? So that's a semicircle, and that's half of that because that's 90. Or 90, so I can figure out that one. It's got to be 180. So AC is the circle's diameter, and it's also the triangle's hypotenuse. Circle's diameter, and it's the hypotenuse of the triangle. So if we have to inscribe a right triangle in a circle, first step is going to be draw a diameter. Just like this. Then, since that's 180 degrees, I know that any angle down here is going to be 90. So draw a diameter, and part 2 is have that be the hypotenuse, and draw a triangle using the diameter. So once I make this diameter, I know that's 180 degrees. That means this angle down here has to be a right angle. Okay, next here, got to find the radius of this circle. Well, this is the diameter here, but we know that since that's the diameter, this angle right here has to be right. And if that's a right angle, we can use Pythagorean's theorem. So we're going to say 10 squared plus 4 squared is equal to the diameter squared. Call that d. So that means 100 plus 16 is d squared. So that's going to be the square root of 116. Which would be 2 times the square root of 29, which means the radius would be the square root of 29, or approximately 5.39. And part 2 over here. Is a triangle obtuse, acute, or right? Is a triangle obtuse, acute, or right? Explain. And is AB a diameter? Well, let's see here. 6 squared plus 8 squared, is that equal to 9 squared? Well, 36 plus 64, that's 81. Well, 100 is not equal to 81, so it's not a right triangle. In fact, since the 81 is smaller than 100, it's going to be acute. So is AB a diameter? No, because the triangle isn't right. Alright, moving on to the next few problems here. I've got to find the measure of angle 1. I'm going to use my protractor here, and the measure of angle 1, well, that looks to me like 90, 100 degrees. Measure of angle 1 is 100 degrees. So that means the measure of arc ABC. Well, this is 100, so that means this arc's going to be 200 degrees. So how much is arc ADC? I'm actually going to switch colors here. Arc ADC, from here to here, that's going to be everything left over. So that's going to be 360 minus 200. So that's going to be 160. So arc ADC is 160 degrees. So if that's 160, then the angle that hits it is half. So that should be 80 degrees. Now we know that the two arcs ABC and ADC and ABC, those are going to add up to the full circle. So that should be 360 degrees when they add it up. If we look at angle 1 and angle 2, well, it's going to be half as much because they're inscribed, so that should be 180 degrees. So what do we notice about the opposite angles here? Angle 1 and angle 2, we notice that they add up to 180 or they are supplementary. So if I'm going to do these problems down here, these two have to opposite, so that means x plus 95 is equal to 180. So x is going to be 85 because they're supplementary. Y and 110 also add up to 180. Those are also going to be supplementary. Those are supplementary, so y is going to equal 70. And let's go over to this one. These angles are opposite. It's inscribed in the circle, so 5x plus x is going to equal 180. So that means 6x is equal to 180, so x is going to be 30 degrees. And once again, this works because this angle plus this angle makes 360. This angle right here, 1 is half of this. Angle 2 is half of the red arc. If they're half of those two arcs, half of 180 is going to be, half of 360 is going to be 180. So the big ideas we have here, if it's quadrilateral inscribed in a circle, the opposite angles are supplementary. They add up to 180. And if we have diameter in a circle, If we have a diameter in a circle, and that angle has to be 90 degrees because that's 180, so that's got to be 90. Inscribed angles are half. Thanks for watching.